Hi, my name is Natalie Wood, and this is my research presentation for EDUU 606. The title of my research paper is From Concrete to Abstract: How the Brain Learns Math. Now, throughout the presentation, I'll be using the acronym CPA a lot, and I figured you'd probably want to know what it means. CPA stands for Concrete Pictorial Abstract, and it is a strategy used to teach mathematics. So concrete means using manipulatives and hands-on activities. Pictorial means pictures, images, drawings, models, and diagrams. And abstract are the equations, the numbers and symbols used, and the algorithms that are used in math. And also, I know the professor didn't ask for it, but I chose this topic. I kind of thought it was important for you to understand why. But I chose this topic because I am a math intervention teacher, and I use this strategy quite a bit, and it's been extremely useful, and it has proven to be extremely helpful for my students. So the key aspects of this presentation are the summary of research on this topic, the areas of the brain involved in this topic, how the topic impacts learning, and the applications and strategies that can be used in the classroom. Here is a summary of research that I found on this topic. While I was conducting this research on CPA, much of the research focused on what CPA is, the importance of using CPA in an elementary classroom, how it is used to support mathematical skills, and how it is used for intervention purposes. There were many studies that I read on CPA, but these researchers were really the most relevant to the topic. In a study that was done by Hung and his fellow two researchers, he discussed the history of CPA, and he mentioned that Jerome Bruner was the one who actually introduced CRA. He called it CRA, but it was Concrete Representational Abstract in the 1960s. And his research talked about inactive, iconic, and symbolic modes of representation as it relates to math. So inactive being manipulatives, iconic being images, and symbolic being the numbers and symbols that we use in a society. Our book, How the Brain Learns Math by David Souza, was all about the parts of the brain that are used for certain mathematical skills and what parts of the brain light up when doing specific tasks. So we learned a lot about Jean Piaget in this class, and I've learned quite a bit about him from other classes as well. And much of his research talks about cognitive development and the importance of stages, how children go through specific developmental stages. This directly relates to CPA as it is done in stages as well. And knowing where a student is cognitively can help us understand what they can and cannot do academically. Sarah Powell is a researcher who focuses heavily on math intervention strategies, why students struggle, and what methods teachers can use. One of those methods that she revisits often is CPA. Jill Bowler is a large influencer in teaching practices of mathematics, and the study that I read was she focuses on the visual mathematics and talks about the part of the brain that lights up as well. Her article also talked about a study that she did with middle school students, where she led a summer camp, and she primarily used visual mathematics for the entire summer session. And not only did students increase their test scores, but she also stated that they were able to see mathematics in a whole new way. And I have tried to look up this name, but I know I'm going to butcher it. But Eros Dumontal, his research focused on the part of the brain that is used for abstract thinking, problem solving, and reasoning. And just like I was talking about earlier, Hung and two other researchers, in addition to talking about Jerome Bruner, they also actually talk about a study that they did out of Singapore using CPA for the factorization of quadratic polynomials and how they used concrete manipulatives to do so. The method was extremely successful, and it helped students understand such an abstract concept like quadratic polynomials. So here are the areas of the brain involved with CPA. So the first thing is to say that, that some people tend to believe that math is only for the left brain. However, as David Sousa stated in our book, we actually use both hemispheres to do specific mathematical tasks. The right is for visual and spatial, such as geometry, and the left is more analytical, used for arithmetic operations. So the three pictures that you see here, I actually put in my paper, and it really kind of shows, I was trying to describe each type of activity, and I thought pictures would do the best thing to do that with. So for concrete activities, the part of the brain that's used is the hippocampus. This would be a student using like hands-on activities, moving actual blocks from the bottom of a 10 frame to a top of a 10 frame, and really using their hands to manipulate the objects to create a different equation. And then for the pictorial or visual representations of concepts, it is the parietal and occipital lobes. And you can see here, this is actually like a visual representation of the number 16. So that would be a pictorial example of a concept. And then for abstract concepts, it is the rostral prefrontal cortex. And as you can see in the image, it's really the symbols and the equations that we use in mathematics. So how does all of this impact learning? Well, so CPA is actually a widely used strategy to help students who struggle with mathematics. And many intervention strategies use manipulatives, pictures, and models to represent the abstract concepts. Students with mathematical difficulties usually missed the concrete and pictorial part and were not provided with enough practice. To understand why CPA is important, it is important to first understand that just like cognitive development, it also happens in stages, and our standards and our expectations have to be aligned with what our students are physically and mentally able to do. And learning about the standards from Powell and the California framework, you find that all mathematic concepts build upon each other, and using CPA in a sequential manner to teach these concepts allows for better retention of the information. So what kind of applications, are there in the classroom to use CPA? So the first thing is use of manipulatives when introducing a new concept. So if a teacher is introducing fractions, really get out those fraction tiles and those fraction strips and using things that students can manipulate with their hands, and then relate it to pictorial, and then relate it to the abstract concept. The second thing is manipulatives need to be accessible to students at all times. I have gone into too many classrooms and see that all of their manipulatives are hidden away out of sight for students and they can't access them. And they really should be able to access them at all times, knowing that they are able to use them whenever they need to. Remove stigmas of, little kid things like manipulatives and finger counting. Many older students think that using hands-on activities and using manipulatives or counting on their fingers is what little kids do, but really encourage students to use whatever works for them. And plus, they will always have their fingers to count on, and I promise you, I don't mean that as a pun. It just kind of came out that way, but yeah, like they will always have their fingers no matter what. And then the next thing is multiple means of representation for tests. So allowing students to show what they know through drawings, models, manipulatives, or even a video of them explaining the steps. One way to show what they know is it's not equitable. And then next, employ project-based learning activities. Have students, show their knowledge through project-based learning activities, allowing them to work in a team and showing their understanding in different ways. And finally, teach multiple strategies and allow the students to use whatever strategy works for them.